Hey everybody, this is Mr. Combs, and I just want to talk about the normal distribution. I want to talk about z-scores, finish up those last two pages, but I thought rather than just post a picture, I would go ahead and go over this example too. So let's suppose that your class took a test and the mean score was 75% and the standard deviation was 5%. If the test scores follow an approximately normal distribution, answer the following questions. Okay, so what I want to do before I answer the questions is I want to create a normal distribution. So I'm going to create a normal distribution, and this actually, it's off a little bit, but oh well. So the mean is 75, and what I want to do is I want to indicate 1 standard deviation, 2 standard deviations, and 3 standard deviations above the mean, and 1, 2, and 3 standard deviations below the mean. Okay? So now, the standard deviation was 5%, so basically what I'm going to do is I'm going to say 75 plus 5, that's 80. 80 plus 5, that's 85. And 85 plus 5, that's 90. Then what I want to do is on this side I'm going to subtract. So 75 minus 5, that's 70. 70 minus 5 is 65, and 65 minus 5 is 60. So now I can answer these 4 questions. Okay? So the first thing I want to know is what percentage of students had scores between 65 and 85. So I want to know what percentage of students had scores between 65 and 85. Well, 65 is 2 standard deviations below the mean. 85 is 2 standard deviations above the mean. So we know by the 68, 95, 99.7 rule that basically 95% of the people had 95% of the values are between are within 2 standard deviations from the mean. Now I want to know what percentage of the students score between 65 and 75. Alright, so 65 and 75, basically that is one side of this 95. So what I'm going to, 5%. So what I'm going to do is I'm going to divide 95 by 2, and when I do that I get 47.5%. Now I want to know what percentage of the students score between 70 and 80. So 70 and 80, that's basically 68%, because it's within 1 standard deviation of the mean, so 68%. And now I want to know how many students scored above 85. So that's going to be, I'll do this in a different color, that's going to be how many students or how many data values are in this green part here. So basically I know this whole side is 50%, and I know from 75 to 85 is half of 95. So that's going to be from here to here is half of 95, and that is 47.5. So all I have to do is take 50% minus 47.5%. And that's going to give me 2.5%. Let's look at these problems involving the normal distribution. Now, we can't use the empirical rule for these. We have to use, because we're given these in z-scores. So we're going to use something else. And one of the things, or the thing that we're going to use is we're going to click on, if you go to our class in My Open Math and you click on Statistics, Resources for Studying Statistics, that second link there is a normal distribution calculator for you. So we're going to use this normal distribution calculator to answer these questions, and it becomes very easy. So notice how here I said I want to find the area under the standard normal curve that is below negative 1.48. So basically on the standard normal curve, here's 0, the mean, and over here someplace is negative 1.48. So I want to find this area. So what I'm going to do is I'm going to go to that website, click below, and then I'm going to type in negative 1.48. That's right? Negative 1.48, yep. And click recalculate. And when I do, that's going to give me that area is 0.0694 or 6.9%. Okay? So that's basically all you're going to do. So for the next one, I want to know the area or the percentage above 1.53. So here's 0. 1.53 is somewhere over here, so I want to know this. So I'm going to click on above, and I'm going to type in 1.53. And I'm going to click recalculate, and it's going to give me 0.063 or 6.3%. And finally, in this case, I want to know the number of scores, or the area under the curve, not number of scores, area under the curve between these two z-scores. So that's going to be negative 1.3, and over here is going to be negative 0.75. So I want to know this area. Well, guess what? We have a between as well. So I'm going to say between negative 1.3 and negative 0.75. Oh, wait a minute. That's outside. What I need is between. So between negative 1.3, sorry, and negative 0.75. So I want to know that little space right there. And so all I have to do is recalculate, and it's going to be 0.1298 or 12.9%, we'll say. All right, one last question here. It says, one classic use of the normal distribution is inspired by a letter to Dear Abby, in which a wife claimed to have given birth 308 days after a brief visit from her husband, who was serving in the Navy. The lengths of the pregnancies are normally distributed with a mean of 268 days and a standard deviation of 15 days. Given this information, find the chance that a pregnancy lasts longer than 308 days. 308 days or longer, okay? And what does the result suggest? Okay, so what I need to do is on the normal distribution, I know that the mean is 268 days and the standard deviation is 15 days. And The wife claims that she gave birth 308 days after her husband visited her. Okay? So 308 is somewhere over here, 308. But what I want to do to use my standard normal curve is I want to change these to z-scores. So I'm going to say z is equal to 308 minus 268 divided by the standard deviation is 15. So when I do that, I'm going to get 2.67. So 2.67 is my, so if this is 0 for the standard normal curve, then this becomes the z-score, 2.67. So what I want to do is I want to find the area under the curve above 308, okay? Which is the z-score, 2.67. So I'm going to say above 2.67, and when I hit recalculate, that gives me an area of 0.0038. That means that I have I have a 0.38% chance. Not 38%, 0.38. So this is less than 1%. So there's a less than 1%, a 0.38% chance that a pregnancy will last 308 days or longer. So what does that suggest? That suggests that the child may not be the husband's. Alright, so what I'm going to do is there's one last page. I'm going to take a look at the last page in another video. So I hope you found this helpful, and let me know if you have any questions.